Good morning to all my fantastic fours out there. I hope you're all well today and ready for another maths lesson. In our last lesson, we were looking at input and output machines with the plan to go on to looking at patterns. But I did think I would step away from that for just a moment and spend a lesson looking at some things to do with zero that should help things speed up. I hope your times table challenges are going well and that you're practicing them, because good times tables and good mental arithmetic are the base of being a good mathematician. It helps speed up all the things, helps you learn the processes because you're not stuck on the small steps in between. So make sure you practice that every day. If you have any questions, you can email me, grade4@worksheetcloud.com. Or if you have any observations, you want to tell me about your challenge, how it's going, you have anything you'd like me to cover in a future lesson, drop me an email. After the lesson, click on the link above so that you can go to the worksheet and just check that you've mastered the things to do with zero that we do today. Right, tricks with zero. I'm not going to go through yesterday's homework. I think it was fairly straightforward, and there is a memo there for you to check if you need. Our lesson goals for today, pretty simple. Be able to use the tricks with zero that allow you to do things a bit quicker and a bit easier. This may seem like a silly thing to start, and perhaps it is a silly thing. It's the additive power of zero. That's its fancy name. But basically, if you have anything and you add zero, you still have what you started with. In this case, anything. So in an example, 5 plus 0 equals 5. And if you want to impress your older brothers or sisters who are starting with algebra, if you had a letter in maths like y, if you have y plus 0, it's still y. So whatever you have, if you add 0, it's still what it was when you started. Seems like a silly thing. It is useful later on in maths. Next up, also quite simple, but pretty important to remember, is that anything times by 0 is 0. So it doesn't matter what you have. If you times it by 0, your answer is going to be 0. So 245 divided by 0 is 0. Sorry, times 0 is 0. If you want to impress those algebraic brothers and sisters, a times 0 is also 0. Anything when you multiply it by 0 is 0. You won't do this year, but in future you may have a look at what happens when you divide something by 0. It's basically an illegal maneuver in maths. You're not allowed to do it. It's undefined. And if you have an iPad and you play around with Siri, you can ask Siri, what is 0 divided by 0? She's got a fun answer for that. Now onto the good stuff. This is where multiplying with numbers that have zeros in them, it makes your multiplying quite a lot easier. Let's jump across to our whiteboard now so I can show you what it is that I mean. Let's say, for example, that I had 10, or let's go 5 times 10. I'm sure that you don't think that's particularly difficult. 5 times 10 is 50. I'm actually going to change that, and I'm going to do it underneath. So what I'd like to show you is that this 0, there's 1 over there, and this 0, there's 1 over there, and 1 times 5 is 5. We'll leave it there. Let's have a look at another one. Hopefully we'll be able to see a pattern starting to develop. Let's do 16 times by 10. I wonder how many of you are able to do that. I'm sure many of you are. 16 times 10 160. I want you to also notice that we have a 0 over there, and a 0 over there, and that 1 times 16 is 16. Let's do one more. 425 times by 10. I don't know how many of you can work that out in your heads. Perhaps if you're somebody who already knows about this rule with 0, you might be able to do it. I can tell you that the answer is 4,250. That is the right answer. I used the trick that I'm going to teach you today. I want you to notice that we have 1 0 in each of them, and that 425 times 1 is 425. Are you starting to see the pattern? I hope you are. What we can notice is that when we're timesing by a number that has a 0 in it, we can just drop that 0 down. So let me rewrite that question 1 underneath and show you what I mean. I'm going to ignore the 0 and I'm going to write it down there. In fact, let me cross it out. Now I'm going to say 5 times 1 is 5 and put it in front of my 0. And in fact, 5 times 10 is 50. So by just dropping my 0 down like that, I made my maths a lot easier because I could do 5 times 1 instead of trying 5 times 50. Now that's quite an easy one, but the same is true for this one. 16 times by 10. I'm going to drop my 0 down. I'm going to say 16 times 1. And now I know that my answer to 16 times 10 is 160. And one more time, 425 times by 10. I'm going to drop my 0 down. 425 times 1 is 425. And my answer is 4,250, and that's the answer to the whole thing. So this is really useful if we've got numbers like that. Let's have a look to see if the same holds true when we use bigger numbers. Let's try 5 times 100. Well, the answer to 5 times 100 is 500. And you'll notice 2 zeros, 2 zeros, 5 times 1 is 5. So the same thing holds true for that one. So now for number 4 and 5, let's use the trick without having to work things out in total. So for the next one, I'm going to go 16 times 100. I'm going to drop my 2 zeros down. 16 times 1 is 16. And the answer to 4 is 1,600. For the next one, I'm going to put it in like this. The only thing I've done differently with this one is I've switched it around. So I've put the 100 in the front. What the 5s were learning just yesterday was about the rule that when you're doing times, you can switch the numbers around and it doesn't make a difference. And I'll do that underneath. So if I've got 4 times 3, it equals 12. And if I've got 3 times 4, it also equals 12. You don't need to know the name of that rule, but basically we could switch it around. So it makes no difference which one of the numbers is in the front. So without complicating it and switching it around, I'm going to take my 2 zeros, put them down there on the end, And then I'm going to say 1 times 425. Hope you're able to read that number. 42,500. That's the answer. So this is definitely quite a useful trick when it comes to these. I've got a couple more. In fact, let me slot in 3 here for you to try on your own before I go into expanding this rule a little bit further. So let's do 6, 7, and 8. And I'm going to see if you guys can manage these. I'll give you a little while to finish those, maybe half a minute, because if you're following the rules, it doesn't take all that long. Okay, if you'd like some more time to finish them off, just pause the video and start again when you're ready. Well, with this one, 6, I'm going to take my 2 zeros and put them at the bottom. You don't need to put the smiley faces in, that's just me because I'm showing you that those are the ones that we're dropping down. Then I do 6 times 1, so 6, and the answer to 6 times 100 is 600. I'm sure many of you would have been able to do that without writing anything down. Next up, I'm going to take my 1 0 and put it down at the bottom. 1 times 71 is 71, and so 10 times 71 is 710. Oh wow, now we've got 3 zeros. What can we do? Well, same rule. We're going to put those 3 zeros down at the bottom. Then we're going to say 1 times 52. And the answer to 1,000 times 52 is 52,000. This rule can be taken a little bit further. Let's change color. What if we have what would we do with that one? Hope I've given you enough time to think about it. Well, as it happens, we do the same thing here. This time I'm going to take a 0 from each of them and put it down at the bottom. Then I'm going to go 4 times 1 is 4, and the answer to 40 times 10 is 400. Now that you've seen the pattern that we can take the zeros from both numbers, see if you can manage this one. I'll put down 11 at the same time while you're still busy. I see that I did 6 twice. Doesn't matter. Right, following the same pattern, 1, 2, 3, 4. I'm going to put 4 zeros down at the bottom. Then I'm going to say 5 times 1 is 5. And the answer to 500 times 100 is 50,000. Up until now, if you've been paying attention, you would have noticed that in every single one of them, one of the numbers has started with a 1. But that doesn't have to be so. We can have different numbers on the front. And the same rule will still apply. Cross out our zeros and put them down there. 2 times 2 is 4. So the answer to 20 times 20 is 400. Try this one. Okay, looking at the first one. Cross out, cross out, cross out. We crossed out 3. We put them down at the bottom. 4 times 4 is 16. There we go. Having a look at the next one, which has lots of zeros. 1, 2, 3, 4, 5. We have 5 zeros. So 1, 2, 3, 4, 5. And 7 times 6 is 42. That's a big number. It's 4,200,000. You don't need to know how to say it, as long as you can write it correctly. Let's look at the next one. 14, we have 1, 2, 3 zeros. 1, 2, 3. I won't put the faces in. 5 times 9 is 45. So the answer to that is 45,000. Okay. There are a couple of pitfalls to watch out for. In fact, there's only one that I can think of right now. Let's say, for example, we have 50 times by 600. Cross out 1, 2, 3. We get 1, 2, 3. 5 times 6 is 30. It's very important that when you do this one, if you get a number with a 0 on the end, that 0 still needs to go in the front there. Otherwise, you're going to get the wrong answer. So don't think that just because there's 3 zeros here, there will always be 3 zeros in the answer. Because if you do this multiplication and you end up with a 0, you could get an extra 0 in your answer. Right, so I just wanted to point that one out just to make sure you don't make that mistake. Okay, that's really probably one of the most useful tricks I can share with you with zeros and multiplication. There are some tricks with zeros and adding, but that's, yeah, we're not going to worry about those for now. Here's one more thing I want to share with you too. Right, so this is really the last thing I want to share with you. And that is, it's not so important, but it will be helpful in the future. And that is that you are not 9 years old. I hope that you are 9 years old, otherwise this won't make sense. But whatever your age is, you can put a 0 in front of it and it's still true. Let's go back to our whiteboard quickly. Right, so my age, I'm so old. I am 39. I could just as easily say I am 039. And let's examine that. If I'm thinking of my age, I have 9 units. I have 3 tens. But because I'm not 100 years old, I have 0 hundreds. Let's just assume I can fit that in. I also have 0 thousands. And so on and so forth, as many as I want to go that way. Now, that may not seem hugely useful, but later on, when it comes to converting different lengths or different capacities, things like that, don't worry about the words if they're unfamiliar with you. it's useful to know that you can put zeros on the front and the number doesn't change, because all you're saying is that in my age there are 0 hundreds and 0 thousands and 0 10,000s and 0 100,000s and so on. The thing is, with mathematics, mathematicians are lazy. Well, maybe not lazy, they're efficient. And what we all agree on is that if it doesn't mean anything or if it's not useful, we just leave it out. So in fact, we don't put it there. And that's why you say that you're 9 years old and not that you're 09 or that you're 009, because it doesn't really have a meaning. One of the other things that mathematicians have all agreed on, I don't know if you've seen a minus number, something like -2, perhaps you've come across that, but did you know that this, my age, is +39? But mathematicians have all agreed that if we have a plus on the front, we'll put nothing. So if it doesn't have a minus, it's a plus. We just agreed it's efficient. We'll all know that if there's nothing there, it means it's a plus. Not something particularly to worry about. Those of you who have seen decimals or touched on decimals, I'm going to show you something else on the other side that's useful. If you've not done anything to do with decimals, don't worry about it. Don't get confused by this with the decimal point or the decimal comma afterwards. But imagine that it was my birthday today, and it's not. Don't send me happy birthday messages. But if it was, then I would be 39 and nothing. There would be nothing afterwards. So you might say you're 9.5. But if it was my birthday today, I would be just 39. And then I would say I'm 39,0 or 39 and nothing more. And like we could put zeros on the front, when we've got a comma, we can put as many zeros afterwards as well. Don't let it confuse you if you haven't done decimals. If you have, it's something useful to know. So we can have as many afterwards as we want, and it doesn't change the fact that I'm exactly 39 years old. Okay, that's probably not the most useful thing for you now, but think of this as Mr. Travis planting a seed in your minds, so that when something comes up in maths later on in grade 5 or grade 6 or grade 7, you'll be like, oh, that's not entirely new. I remember when Mr. Travis told me about that. Yes, okay, I can do this. So my idea is not necessarily that you have to know that yet, but it's just planting a seed for something in the future that will hopefully grow into mathematics knowledge later on. That's all we have for today. If you have any questions, if anything was confusing you or worrying you, just email me, grade4@worksheetcloud.com. Yeah, I'm happy to receive your emails and respond. And after the lesson, just to check that you fully understood these tricks with zero, particularly timesing when there's zeros in, click on the worksheet link above, do the worksheet, and hopefully you'll see that this is a useful trick that you'll be able to use in class. Probably one of those things you use more often than some of the other tricks that I'll teach you over the course of the next few weeks. Have a great day. Goodbye.